Page 424, rectangles. So far we've talked about parallelograms, and then what we're going to do is we're going to hone into specific types of parallelograms, all right? And the first type we're going to talk about is a rectangle, all right? If a parallelogram is a rectangle, then the diagonals are congruent, all right? You'll also notice something specific about a rectangle by these little notations right here in the corner. We have 4 right angles. So here are some properties of rectangles specifically. You do need to know these properties, and you do need to know which properties go with which parallelogram, all right? So opposite sides are congruent and parallel. That's actually true of a parallelogram, period. Opposite angles are congruent. That is also true of a parallelogram. Consecutive angles are supplementary. True of any parallelogram. Diagonals are congruent and bisect each other. All right, diagonals are congruent and bisect each other. So parallelograms, we know that they bisected each other, but they weren't necessarily congruent. For a rectangle, they are congruent, and they also bisect each other. And then the last thing, which is the most familiar, all 4 angles are right angles. All 4 angles are right angles, all right? And so that is a rectangle. So the first example, quadrilateral MNOP is a rectangle. If MO is 6x plus 14 and PN is 9x plus 5, find x, all right? So the first thing you would do is you want to make sure you know what they're talking about. So we have MO, that is this diagonal right here. And they've given us PN, that is this diagonal right here. We just found out that in a rectangle, which is what they told us it is, a rectangle, my diagonals are congruent. If those are congruent, when we solve for x, we're just going to set those equal to each other. 6x plus 14 equals 9x plus 5. Solve for x by moving all your x's to one side and all of your numbers to the other. So we will get 9 equals 3x, so x equals 3, which is what they asked for. Find x. All right, diagonals are congruent. Easy enough. So we're going to have several different types of parallelograms. Some things are only going to apply to the parallelogram itself, and then we're going to start getting specific. So you need to start, in however you memorize stuff, you need to start having like rectangle. Here's all the characteristics of a rectangle. And there are some that will go along with other types of, it will fall into more than one category. So you will see other types of parallelograms where the diagonals are congruent, but then there's more specific things that happen. And so you want to start making some type of chart so that you can memorize these. All right, let's look at the next. All right, example 2. Quadrilateral ABC is a rectangle. So that's the first information. It is a rectangle. Find x. Find x. All right. Since this is a rectangle, we don't even have to worry about whether it's equal to something else or anything like that. We, for x, we can just say, what do we know about every angle in a rectangle? Every angle in a rectangle is how many degrees? 90 degrees. So for this first one, if I'm looking at this right here, I know that this is 90 degrees. So I'm going to say 9x plus 20 plus 4x plus 5 should equal 90 degrees. Combine my like terms here. And then solve, of course, for x. X equals 5. All right. They then want us to find y. All right. So if you flip the page, they want us to find y. Now, the only thing we know so far is that just like in every other one that we've looked at, these are alternate interior angles. So we can just solve for y by setting those equal to each other, just like we did on the first. So we can just say 4y plus 4 equals y squared minus 1. Just like in our bell work, you are going to want to set them all equal to 0 here. So you want to subtract over, and I always leave my squared positive. So whatever's going to make that positive, I'm going to leave it. So I'm going to subtract my 4y and my 4 to make it equal to 0. Y squared minus 4y. I have a negative 1 minus a 4. All right, so that's going to be negative 5. And then we're going to factor just like we did with the bell work. So we're looking for things that multiply to give you negative 5 and that add to give you negative 4. All right, so what multiplies to give you negative 5 and adds to give you negative 4? Positive 1 and negative 5, right? So we set each one of those equal to 0. So y can either equal negative 1 or positive 5. You do want to plug this back in to make sure it works. So just like on the other one, it was x squared. We plugged it back in and those were legitimate sides. If I plug this back in here, I'm going to have a little bit of a problem. If I plug in a negative 1 here, I will get 0, right? And if I plug in a negative 1 here, I'm also going to get 0. My angle measure cannot be 0. So negative 1 will actually not work here. So the only thing y can equal here is positive 5. So you do want to check and make sure that it doesn't cause an actual problem. Like if you plugged it in and it was like your measurement's negative, well, your length can't be negative. So that number does not work. So there are times when you will actually solve for it like we did here. And when you plug it back in, you're like, nope, that's not a valid answer. So the only other one that is the valid answer. And the one way you can prove it is if the diagonals are congruent. If you have congruent diagonals, then you can say, well, this is a rectangle or at least a type of rectangle. And so one of the things they use in building is what's called squaring a window. And we'll get to what a square is. A square is actually a more defined version of a rectangle. But squaring a window is proving that you have 4 right angles when you're doing a window. Well, the easiest way to prove that is measuring the diagonals, all right? Versus trying to figure out that it is a right angle, you can measure the diagonals. If the diagonals are equal, you have right angles. You have a rectangle, a type of rectangle. And so this example they gave you, he's building a treehouse for his younger brother. He measured the window opening to be sure the opposite sides are congruent, all right? He measured the diagonals to make sure they are congruent. This is called squaring the frame. How does he know the corners are 90 degrees? He does not know that from the sides being congruent because you can have a parallelogram and the sides are congruent. So that's not going to help him know that this particular window has a 90 degree. But once he measured the diagonals, he then automatically knew it's going to be a rectangle. It's going to have 4 right angles. All right, so just having sides congruent is not enough. All you've proven is that you have a parallelogram. You have not proven that it's a rectangle, all right? And so when we did the last one, all we had to do was say, oh, all 4 sides are congruent. I must have what I need. Now we've gotten more specific, all right? So if you look at the next example, coordinate geometry, they've given us a quadrilateral. That just means 4-sided figure. And they've given us the vertices. Determine whether or not it is a rectangle, all right? They've given us 2 options to do this, using slope or using distance formula, all right? So here's the deal. If I use slope, what am I going to try to prove with slope? If I use my slope to prove that it's perpendicular, what will I need to be looking for? Negative reciprocals. So I must show that the slope of FJ has a negative reciprocal slope of JH, all right? So that means these 2 need to have the same slope. They need to be parallel. And these 2 also need to have the same slope, but specifically their slopes need to be negative reciprocals of the other 2, all right? So I do need to do all 4 because I don't want to have one right angle and then the other 2 not work out, which isn't going to ever work. But you want to look at all 4 slopes is what you want to do. So let's look at those. So the first thing you need to remember is your slope formula, which we used in the prior examples that we've done, y2 minus y1 over x2 minus x1. And then you just want to take each line individually. So if I go from F to J, I am going to subtract my x's and my y's. So my y is negative 1 minus 2 over negative 4 minus 2. So I will get negative 1 minus 2, negative 3. Negative 4 minus 2 is negative 6. That gives me 1/2. All right, if I look at the next one, G to H should have the same slope. So if I look G to H, I'm going to do the same thing. Negative 5 minus a negative 2 over negative 2 minus 4. Negative 5 minus a negative 2 is negative 3 over negative 6, 1/2. So I know that those two are parallel. So I need to do the other two. So I'm going to say F to G. F to G. So F to G. And I'm going to do the same thing. Negative 1 minus a negative 5 over negative 4 minus a negative 2. Negative 1 minus a negative 5 gives me what? 4. And negative 4 minus a negative 2 gives me negative 2, which will give me a negative 2. That is perpendicular. And then I'm going to do my last one, which is J to H. J to H. Same thing, 2 minus a negative 2 over 2 minus 4. That's going to give me 4 over negative 2. So now I know those are, the opposite sides are parallel and they are perpendicular to the other ones, right? So if you use distance formula, the first thing it does is it shows that it's a parallelogram, all right? And then once you know it's a parallelogram, then it showed that the diagonals are congruent, all right? The diagonals are congruent. So when you do diagonals, you're not going to do the same ones that you did for slope. When you do your diagonals, you're actually going to go from G to J and then F to H. And if you use your distance formula, you will be able to show that those two are congruent. So x2 minus x1 squared plus y2 minus y1 squared. All right, diagonals. All right. Because there are going to be times when you have 4 right angles and then you need to prove something else besides it. So when we get to like squares, you're going to have to use the slope and your distance formula, both. So make sure you know them all. All right, number 4, it's a rectangle. They told you that one diagonal is 30 minus x and the other diagonal is 4x minus 60. You should have just set those equal to each other and you get that x is 18. X is 18. All right. For 5, they told you again it's a rectangle. Now for this one, they gave you the whole diagonal in R, 2x plus 10, and then part of the diagonal in P is 2x minus 30. So you should have doubled this to equal the whole because it cuts it right in half. And so when you do that and you solve for x, you would have gotten that MP is 40 because it wanted you to plug it back in, but all you had to do is plug x back into NP because they're the same. All right, so all of your diagonals are the same, which means all of the halves are the same. Does that make sense? Quadrilateral QRST is a rectangle. Find each measure or value. All right, so for the first one, they just wanted you to solve for x, 5 or negative 2. 5 or negative 2. So one or the other there. Because when you plug it back in, you would get x squared minus 3x, what, minus 10, I guess. And so you would have x minus 5, x plus 2 when you factored it. So those would be your options. And then when you solve for this one, 52 or 10, 52 or 10, depending on which x you used, This together. So we know that this is congruent to that because they're alternate interior angles, right? And so we're going to say 3x plus 11 equals x squared plus 1. We will subtract these guys over. And we'll get 0 equals x squared minus 3x minus 10. Factors of negative 10 that give you negative 3 are going to be x minus 5, x plus 2. When you set those equal to each other, are equal to 0, you'll get positive 5 or negative 2. Positive 5 or negative 2.
See, I subtracted 1.
Solve for x, you need to plug it back in. So, I mean, the easiest thing, I don't know which is going to be easier, but if you plug it back in up here, right, you will have to subtract from 90, really, to get the one that you're solving for. You're going to have to kind of work your way around. Either way, you're going to have to do it. So if I plug in a 5 here, I'll get 26. And then I would solve for this other angle here, which would do what? If this was 26, what would this one be? This whole thing is 90.
64.
If I plug in a 5 here, 26, right? And this one's going to be 64. That means this is 64 because this is an isosceles triangle. So then how do I solve for that guy? Yeah, so we'll say 128 and subtract from 180. That's where we get our 52, right? All right. And then if we do the other one, so let's say we're going to plug in a -2 here. So plug in a -2. This would just be 5, right? Which would make this other guy 85, right? He'd be much bigger. And so that would make this 85 and 85, right? And so if I add those two up, what do I get? 170, and I subtract from 180, which would give me the 10.